Hi everyone, David Maley here with Tech Know-How, and today we're here for part 3 of this exciting series on data cleansing and exploratory data analysis in Python. Again, we're using the data set for selfie deaths, which is publicly available on the internet. If you haven't watched parts 1 or parts 2, please go back and watch them. Part 1 is where we load in all the libraries, do a little data cleansing, remove some nulls, and in the data. And then part 2, we go through and do several checks, graphs, scatter plots, line graphs, all kinds of stuff to look at the data. And we found some outliers, some spikes, some interesting dates and stuff like that. So this part, we're going to go and drill down into some interesting insights based on the data we saw previously. And we're going to bring it all together in a professional package, kind of like what you would do for a typical data science task or project. So this is part 3, drilling down to some interesting insights and bringing it all together. So we're going to filter the original data frame after the nulls are removed. The data frame is now df1. We're not in df. df is the one with the nulls still there. So we want to see if we can identify the number of injuries, casualties from fire in that one big event. Last time we found this huge dot right here for fire between 2017 and 2018, and we saw this huge spike here between 2017 and 2018. So we're going to look at that a little deeper. So if we filter data frame 1 to 2017 to 2018, okay, and display the head and or tail, let's see what happens here. So if we look at this, we're doing df1 date, we're greater than or equal to 2017, and df1 date less than or equal than 2018. So greater or equal, so it's 2017 to 2018, that year range. Okay. So, and we put that into this df2 underscore 2017 underscore 2018. So we know what it is. It's data frame 2. It's from 2017 to 2018. So then if I look at that and I look at the head, and then I look at the tail, what we'll get is this data down below. Now the head is not showing because I already did that one. I could redo that one if we wanted to. I could go and put a number sign here and just run that as is. That'll give us the head. And then remember, this is just for, so even though it starts at 114 to 118, I know there's data before that. That's because we cut out 2016, 2015, 2014, 2012, all that stuff. Okay. And it's only showing the top 5. So the head, and by default here, is 5 in R, I believe it was 6 if I'm correct. But anyway, it doesn't matter. You can always change that by putting a number inside of this, and I could say 4, and then it would just give me 4 rows. So that's the head. When I look at this, I see India, Pakistan, Croatia, India, nothing really standing out there. Electrocution, transport, drown, transport. These are selfie deaths. If I look at the tail, so let's look at this. Let's get rid of this one. I can just leave it there. It'll overwrite it anyway. And run that. That gives me the tail. And what do we have here? We have India, United Kingdom, Malaysia, United Kingdom, Mexico, and we have some falls, right? So now that really doesn't tell me everything I need to know. There's more than just that. There's many more occurrences than just those two. They're not identifying that fire. Remember, we're looking for a fire, right? Fire right here, not animal, but fire. So what we need to do is sort by type and then display the first 20 rows. An alternative would be we could do a sampling of n rows depending on what we're looking for. But in this case, and I'll show you the data for that. But it all depends on what you're looking for. In this case, we're using the head function to set the 20 rows, or set to 20 rows, which will suffice. It doesn't matter. So if you want to do the sampling, you would use this code right here. Our data frame, the 2017-2018 dot sample n equals 30. So we highlight it better for you. So it's basically this sample n equals 30, random state equals 2. Random state could equal whatever you want it to, and it'll change. It's like a key, and you go through and you can randomize the data. We're not going to do that here. So what we're doing here is plot that figure. This figure size 26, 20,6. Our data frame, new data frame with 2017 to 2018 data. Remember, it's df2 underscore 2017 underscore 2018, so we know what it is. Sort values by type, ascending equals false, and in place equals true. And then we put df2 2017 2018 head 20. So it's ascending is false, right? So it's descending, obviously the opposite of ascending. And if we look at this, or actually it's just not ascending, but It's not in any specific order, but what we're looking for is something that stands out. So we got row 114, 124, 148, 130. So actually it's not descending or ascending by type. And we look at this, so it's grouped by type. That's what this does. To better explain it to you right here, by type. That's the most important part right there, by type. And by doing that, we've got transport and fire. And boom, look at that. There's the 48 right there. Look at that. See it right there? 48, fire. 48 people are injured. We're standing too close. Too close to what? I don't know. So this is where I'm going to show you a little trick here. It ends with these 3 dots on anything that it thinks is too long. It concatenates them or, makes it smaller. And so what we need to do is we want to see that whole data on that. That obviously happened 7/16. There was a fire. So to see the entire description for that event in India, not the truncated, I was not concatenated, I was thinking of truncated. Truncated text, we need to set the max display width option to none. How do you do that? Right here, let me show you. Okay, so if we display row 141 description field, which is this, right? 141 is right here, this guy, right? If I display this description field, which is this right here, description, what happens? Well, if we print df.description.loc141, that loc is how you use to get that exact row, right? So I've got df.description.loc141, and that gives me the truncated answer, which we still are right where we were. 40 people are injured. We're standing too close to what? We don't know at this point. Right, so now what we have to do is figure a way to get that out. So display the full text for that same description by setting the column width to none, which I said earlier. So what you do is this guy, pandas.set option, display max column width, set display.max column width, and that's in single quotes, comma, none. See it right there, comma, none. And you do the same thing. So then when we do this, the same exact thing we did here, df description.loc141, with this display column width set to none, then we get this. Look at the difference. Now we get the whole thing. So now it says 48 people were injured when standing too close to a burning bakery in Chennai, India, to take selfies. They repeatedly ignored warnings advising them to move away from the blaze. Maybe they couldn't get away when it got too hot. Maybe it exploded. I don't know what happened, and it's unfortunate that it did happen. But 48 people were injured. It's not sure if they died or not. It doesn't state in there. This is selfie death, so I assume that they died or they died later on afterwards. Again, it's a sad event. It's sad when anybody dies. But that's how you get the see the full description. By default, you only get truncated and you only get this, and you won't know what really happened in a longer text column. So now that we have that data and we've looked and we've seen that India had the highest number of selfie deaths, but that could be skewed because of this one fire event. So when we look at this, we want to write a results and conclusions and then a recommendations. See that here? So you want to write recommendations. First, you want to write results and conclusions. So our conclusions are, we're just going to take the data that we saw and state what we saw. Once we cleaned up the data a little, we found that India had a much higher number of selfie deaths than any other country. It was higher than the next 5 countries combined. Next, we see that the fire was the main type of selfie death and or injury. There were far more fire-related deaths and or injuries than all other types combined. Now, where it gets really interesting is when we plot the data over time, and we see a large spike between 2017 and 2018. So we saw this is usually indicative of an event or massive casualty, like a large fire or similar, flood, something like that. So we next did a scatter plot, and this showed a large black dot between 2017 and 2018. Remember that black dot we saw was the biggest one on the screen, or in that graph, under fire, that type of fire, nowhere else. We then filtered the data to just those 2 years and sorted it by type. We saw one row for fire with 48 deaths, injuries in it. The country, it was India. The exact date was July 16, 2017. Per the data, 48 people were injured by being too close to a burning bakery. I'm sure there are other interesting insights in this data. The purpose of this task or this video was to give you this 3-part series to give you a taste for some typical data cleansing and exploratory data analysis, EDA, like we would actually do on a real project. Now, there's many other avenues, shoots we could have taken with us, looked further into the different types and things like that, and I'll tell you that in the next sections of recommendations. This was just a partial look into this data. There could be other valuable insights garnered from this same actual data. There are the ones that these are the ones that jumped out at us with a little data cleansing and exploratory data analysis. There are some other dark dots from the scatter plot we saw above in Part 8 for electrocution in 2021 and drown between 2015 and 2021 that might be interesting to look into. Other interesting ideas worth looking into. Why do falls, which are regular each year for 6+ years, suddenly lower in 2021? Maybe there's been an awareness made of the risks of selfie injuries and deaths, and maybe that's playing a role. Maybe no selfie zones, or there's some new areas where they do have no selfie zones in national parks and stuff, and maybe that could be having an effect on curbing this. It is weird that there are no electrocutions for several years and then a big one in 2021. What could have caused that? We could look into it through the same exact process we used above for to find out the fire for this one in India in 2017. So what could have caused that? We don't know. We can look into it. We can easily use the code and ideas above to look into these ideas and more and see if they could lead to actionable insights. And that's basically it. So that's how you write up an actual project. So we showed you from the beginning the purpose, that put your name on it, the purpose, what are the parts we're doing. In this case, we loaded the libraries in. So go back. This is parts from video 1. Loading the data, look at the data, pull out the nulls, identify the nulls, pull out the nulls without losing data. Part 2 is where we go and look at the data. We did all kinds of graphs and plots, and to identify, like India was obviously had a large number. And then we looked at the types, and the types was fire had a huge number. And then we saw, we went and looked at it in a time series, and we looked at it over time. We saw a huge number of 48, which looked really weird. Kind of like an outlier there. And then we did a scatter plot, and we saw this big dot right here. There's some other dots that might yield some interest. That's what I was talking about later on. And then we went through and dug into a little bit deeper, brought in the meanings from it, filtered the dates, and got the exact event that happened, showed you how to untruncate the data, and how to show your results and your conclusions, your recommendations. So I hope you found this interesting and informational. Complete walkthrough from the beginning to the end of doing some data cleansing and some exploratory data analysis in Python and Jupyter Notebooks. I love Jupyter Notebooks because it's so easy to document stuff in here. Thanks again for watching. If you haven't gone or watched videos 1 or 2, parts 1 or 2 of this series, go back and watch them. Watch all parts and then try this on your own. Try with a different data set. Try the different plots and see what your data shows. That's how we learn. And it's what makes data interesting and fun. Thanks again for watching. Please take a moment to subscribe, like, and share, and have a great day. Thank you.